Hello ladies and gentlemen of Year 9. This PowerPoint is hopefully going to help you with some pretty tough areas of algebra and linear graphs. A lot of what you may have done previously has probably been on more on graphing. Now what I want to concentrate on here is the actual use of algebra to do a lot of problems with linear graphs. So not so much the graphing of them, but using a lot of algebra for that. Have a look at something that I hope you're all pretty familiar with though at the moment, and that's finding the x and y intercepts, because this is one of the very first things you would have learned using your old linear equations techniques to solve and find x and y. So let's have a look at a couple of problems here. We've got this 2y minus 3x equals 12. Now what you've noticed already, of course, is that it's not in y equals mx plus c mode. So that makes it a little bit more difficult for us. We can't just graph it using the techniques that we know so far. So we're going to find the x and y intercepts. And that goes back to, of course, that key rule that when you're finding x, the value of y is 0. And when you're finding y, which I'll show you on the next equation, the value of x is 0. So over here, I've written the equation, and I've actually skipped a step. I've changed 2y to 0, because if y is 0, 2 times y is 0, so we just write the 0 there, skipping a little step. Therefore, get rid of the 0, negative 3x is equal to 12, x is negative 4. And over here, the same thing, I've substituted the x's, or the 3x for 0, because if I'm finding the y-intercept, then x must have a value of 0. It comes down to 2y equals 12, and then y equals 6. Let's have a look at that graph. This is what you'd be asked to show. Just a small graph would be needed. You wouldn't even need graph paper, I would imagine, for most of this. And what we'd clearly mark there is you'd see that the x-intercept is clearly labelled and the y-intercept is clearly labelled there again. Just highlighting that point again, that I'm on the y-axis right now, so that means that x has a value of 0. I'm not this way, I'm not that way, I'm right on the axis. Similarly here, I'm on x-intercept, so it means that y has a value of 0. I'm not anywhere up here, I'm not anywhere down there, I'm right on the axis. Alright, it gets a bit harder after this. Not so much the first time though. You would hopefully all understand how to find the gradient. You can look at a line and see how far across, how far up or down you go using the formula rise over run. It's pretty easy to get from a graph. What if we didn't want to do the graph and all we wanted to do was give you the coordinates of 2 points on the line and ask you to find the gradient? Well, you use this formula here. Now, it looks a bit confusing, but y2 just simply refers to the second y coordinate, y1 the first y coordinate. Similarly, x2 is the second x coordinate, and x1 the first x coordinate. Let's have a look at something. So find the gradient of the line joining these points. Now, here's your second y coordinate, here's your first y coordinate. Here's your second x coordinate, your first x coordinate. Let's substitute those into that formula. So when we substitute in these to replace these, we end up with this equation, which simplifies down to this, which equals 2. That means that the gradient is 2. Now, if we were to graph that and join those points and graph that, you would find that it had a gradient of 2. I won't do that now, but that's just a simple way of finding the gradient using this formula. Now, if you haven't been taught that, you will be. So if you can clearly see here that here is the second y coordinate, 2. Here is the first y coordinate, negative 2. X is 3, take away 1, simplifies down there. Terrific. Let's have a look at something else. You might be given some points and say, okay, are these coordinates on the line? Now, this is the coordinates here I'm talking about. So, negative 3, negative 2, and 1, 6, are they on the line? Now, I accidentally brought up my next sentence too early, so just ignore this for the moment. Are they on this line here? Now, again, we could graph it and just see if those 2 points are on the line. But what we're trying to do is to get you to move away from graphing and use algebra to find out these solutions. What we have to now check is, this should have come up right now, does this satisfy the equation? Now by satisfy the equation, you'll see what I mean in the next step. So this is what we're going to do. Here's the equation y equals 2x plus 4. Now, I'm just choosing any one of these sets of coordinates. We've actually chosen this one to avoid using negatives, and all I'm doing is I'm swapping the x value with the x value in the brackets and the y value with the y value in the brackets. So 2x plus 4 becomes 6 instead of y, equals 2 times 1, because the x value was 1, plus 4. 2 times 1 is 2, plus 4 is 6. This equals 6, this equals 6. Okay, 6 is equal to 6. That's what we talk about when we say that it satisfies the equation. So because we ended up with 6 over here and 6 over there, that satisfies the equation. That coordinate, or those two coordinates, will be on this equation when we graph it, and I'll show you that in a minute. Let's, however, look at the other one, the same equation, but we'll use these sets of coordinates now. Now I'll move a bit faster here. Y equals 2x plus 4, y swaps for negative 2, equals 2 times the x coordinate, which is negative 3, plus 4. 2 times negative 3 is negative 6, plus 4 is negative 2. We end up with negative 2 equals negative 2. So these coordinates also satisfy the equation. So the answer is simply yes, those two coordinates will be on that line. Now, as I said, you could do it by graphing, but we want to do it by algebra because we think that's a better way and a faster way. Let's have a look at it graphed anyway. Here's an example of this particular graph. Now, this actually is the line of y equals 2x plus 4. If you have a little look there, you'll notice that it's got a y-intercept of 4, and you should notice no matter where you go from, that we've got a gradient of 2 happening all the time. So cross 1 up 2, cross 1 up 2. And the red arrows clearly mark, well, 1, 6 is clearly on the line. I'm at 1, 6 right now where this arrow is, and I'm also at negative 3, 2, negative 2, sorry, negative 3, negative 2 right here as well. So you can graph it and see that they are on the line, or as we did, we used algebra just to prove that those two coordinates are on the line. Now, some pretty difficult algebra here, I know, but you have done an equations unit already, so a lot of this sort of stuff shouldn't be that foreign to you. You know, it might be at the back of your brain and need to come forward a little bit, but it shouldn't be totally foreign to any of you at all. Let's look at another thing you might be asked. You might be asked to try and find where two lines intersect. Now, clearly I've had a little animation problem. This shouldn't be here at the moment, but you'll see where that'll pop up later on where it's supposed to be. So we'll just ignore that for the moment. And again, you could graph the two lines and say, oh, okay, they intersect just there. Or where will they intersect? Or again, we could try to do it by algebra. So let's have a look at these two equations. If we were to graph y equals 2x plus 2 and y equals negative 2x minus 1, will they intersect, and exactly where will they intersect? Well, this is what we do. You can see here that I've taken the y's out of the equations, and I've done a linear equation similar to what you've done in the past, where the x, or the unknown, or the variable, is on both sides of the equation. So I'm saying that 2x plus 2 is equal to negative 2x minus 1. If we solve that the way we've been taught, I've added 2x over here and added 2x here, then I've subtracted 2 divided by 4. We found that x is equal to negative 3 over 4. So they'll intersect at the x value of negative 3 over 4. But what about the y coordinate? Well, this is what we do next. We take any one of these equations. Now, I've chosen to take this one. We could have done it with this one as well. So you could do it with this equation or this equation. You only need to choose one. So I've chosen this one. And what we do is now that we know the value of the x coordinate, we can substitute it in just there. So y equals negative 2x minus 1 now becomes y equals negative 2x minus 3/4 minus 1. Now, putting a fraction in there hasn't made it the easiest equation to do. Guys, you're allowed a calculator, so that shouldn't be too hard. What that actually becomes is 1.5 minus 1, which actually equals to 1/2. So y is equal to 1/2, x to negative 3/4. That means that they will actually intersect at the coordinates of negative 3/4 and 1/2. Let's graph them anyway and have a look. Now, look, not the clearest graph here. It's nice and clear, but it's just a little bit smaller than we'd like, but I need to do that to fit it on the page. If you just have a look here, you can see that I'm at about negative 3/4 on the x-axis. I'm not quite at 1, and I'm exactly in line with 1/2 right there. So there's your intersection where the arrow is showing you, and you can see they're intersecting right there. Now again, I've shown you how it happens on a graph, but what we're trying to get you to learn is the actual process using algebra that I did up there. Alright, what are we going to do next? Supposing I give you two coordinates. So I've given you the coordinates of 1, 1 and 3, 7. Now, I want you to find me the rule for that. So the rule is the equation, and again, I know I'm sounding like a broken record here. We could graph or could plot those 2 points, then graph the equation, and you'd be able to tell what the rule is by the methods that we've been taught before. But again, we're trying to do this via algebra and not via graphing. So that's what we're going to do here. We're going to use this formula first to find the gradient. So we did this in an earlier slide. This is the formula for finding the gradient. Remember, this is y2, this is y1, this is x2, this is x1. So use that formula to find the gradient. Let's speed it up a bit because we did this earlier. So it becomes this, which becomes 6/2. It has a gradient of 3. Now we know the gradient. All we have to do is try and find the y-intercept, and we can graph this like we all know how using the gradient y-intercept method. Well, in actual fact, we won't graph it. Once we know the gradient y-intercept, we actually just know the equation. So let's look at what the next step is. Okay, y equals mx plus c mode is what we learned first of all. I know we've looked at some equations that weren't in that mode, but we learned what y equals mx plus c. Now, what we're going to do here is we're going to substitute in these coordinates into that equation. Pardon me. So I'm going to swap the y for the y coordinate. Don't worry about these two. I've just chosen to do it with this one. So this set of brackets are these coordinates. 7 equals 3 because we already worked out the gradient is 3 times 3 because it was the x value of 3. So I'll say that again because I just lost my place for a minute there. I've swapped y for the y value. I've swapped x for the x value, and I'm multiplying it by 3 because we already worked out that was the gradient. So we get 7 equals 3 times 3 plus c. So 7 equals 9 plus c. A little bit of clever take away 9 from both sides in solving. We find, therefore, that the c, which is the y-intercept, is equal to -2. Now again, we haven't graphed, we've used algebra. Algebra to find the gradient. Once we know the gradient, a little bit of equation solving to find the y-intercept. Therefore, if we know that, m has to be 3, which is the gradient. We've done that. C is -2, which is the y-intercept. Therefore, the equation must be y equals 3x minus 2. Next one. Finding the equation of the line parallel to the line with this equation passing through that point. Now that's a lot of confusing language there, isn't it? It actually sounds super hard. It really is quite simple. When you have a look at it, you'll sort of probably give a bit of an, I see it. It's that simple. So here's an equation. Y equals -3x plus 2. Now, I've had a little animation problem again. -3x plus 2 is your equation. And it's going to pass through this point. all I want you to do is give me another equation that is going to be parallel to that one. Here's the trick to it. Parallel lines must have the same gradient. So my stepping point's always going to be y equals negative 3x, because it has to have the same gradient as the previous one, otherwise it won't be parallel. The next part is super easy. Look at this. X value of 0, y value of negative 2. That actually is the y-intercept. So this one passed through 2, this one's going to pass through negative 2, so they'll be parallel because they've got the same gradient. So again, a parallel line must have the same gradient, and because I gave you the y-intercept coordinates, you've got your y-intercept. So let's have a little look at it. So y equals negative 3x plus negative 2, which is the same as saying y equals negative 3x minus 2. So this bit here that says plus negative 2, you know from your negative numbers, you can rewrite that as take away 2. So y equals negative 3x minus 2, that's the actual equation. Now, you haven't been asked to graph it, but I'm going to graph it for you just to prove what I've just shown you above. So let's have a little look at the graph. Here's the first equation in red. Y equals negative 3x plus 2, going on a gradient of negative 3 and passing through 2. Here's the one we worked out via algebra, same gradient, negative 3, and we're cutting through the y-axis at negative 2, just like the equation said there. Didn't need to graph it, I just wanted to show you what it looks like. So again, it's using algebra and some substitution to find these things. Alright, I think we're up to the last one, are we? Yes, we are. At some point you might be given a line segment. Now, if you can't remember from your geometry, a line segment actually gives you a starting and a finishing point. So it won't have arrows on it. It'll actually have dots to show that we start there, we finish there. What would happen if I asked you to find the midpoint of that? So, let's supposing we had a line that went from negative 2, negative 5 to 2, 7. Now, it doesn't go past them. It starts at negative 2, negative 5. It travels to 2, 7, and it stops. Well, that's what that would look like. So if you have a look here, I'm starting at negative 2, negative 7 right there. I'm sorry, negative 2, negative 5, negative 2, negative 5. And I'm traveling all the way up, and I'm in line with the x value of 2 and the y value of 7. Now, if I had just a horizontal line or a vertical line, it would be really easy to tell me how long it is, and therefore what the midpoint is. But because we're going diagonally through the grid, it's really hard to know how long that is. And it's really hard to actually say, well, where would the midpoint be? So we have some more algebra again. If you just have a look just right here, I've just shown you this, which is the horizontal movement, which means I go across 4 numbers and up to get to there, 5 and then 7, which is 12 numbers. So I'm going across there and up there. Now, I know I'm showing you that, and again, you would be required to do this without a graph. The whole idea is that you can use algebra and not use a graph. I'm just showing you what we're looking for. So we're going across there and up there. So it's across 4, up 7. But without a graph, how do we know that? How do we know it's across 4 and up 7? Sorry, say that again. How do we know it's across 4 and up 12 if we don't have a graph? We can see I've marked the midpoint for you already. So there's the midpoint right there with the arrow. Because if I went across 4, well, to go halfway across would be to go across 2. And if I was going to go up 12, well, instead of going all the way up and go halfway up, I'd go up 6. That gets us to the point of 0, 1. But we have to do it without a graph. So we have this formula. This one here is just how we find the midpoint of y. And then this one here is the midpoint of x. Now again, we're using these y2 and y1 coordinates. So y2, y1, x2, x1. Notice we're adding this time and then we're dividing by 2 to get like an average, which is going to be the midpoint. So you follow this formula, which you don't have to remember. You're allowed to bring A4 sheets into exams and things like that. So you can use this formula. So swap them, bit of substitution, put the x and y values in the correct places. And what we end up with is the y coordinate becomes 2 over 2, which equals 1. The x coordinate becomes 0 over 2, which is just 0. Now I've got them in the wrong order. I've got y first and y first and x second. That doesn't matter. We'll just swap them around. So the correct coordinate by using algebra is 0, 1, which we found to be the exact coordinate when we graphed it. So algebra and solving it by substitution does just as good a job. Now, I lied before when I said the last one. That was the second last one. So here's the last one. You might be asked again to find the length of a line segment. And again, if it's going at a diagonal, and I'm using exactly the same line segment as we used in the previous slide, if it's going at a diagonal, then there's no real way to tell exactly how long it is. Vertical, yeah, easy. Horizontal, yeah, easy. Now you might notice just my little blue ones have just slipped off their lines a little bit there, but I think that you get the picture of it anyway. Didn't notice that it just slipped off. So we can see we've got to get the length of this line segment, which is really, really hard to do because it's on a diagonal. So what we're going to do is the following. We are going to use these coordinates and we are going to find the length of the line segment by first of all doing this. I want you to find the difference between the two y coordinates and the two x coordinates. Now there is a formula, and I've deliberately left it out of this because it's got a square root symbol and all sorts of other squared symbols, and it's quite complex. So teachers, I think, would rather explain that face to face to you. So we're going to just do this a little bit differently, but there is actually one formula to follow. Now if you don't know that, I hope you know difference means to take away. So to get the difference between the two y coordinates would simply be to take them away. So if you have a look what we've got here, we're going to do y2 minus y1 again. So it's 7 take away 5. Sorry, I apologise for that. 7 take away negative 5, which gives you a total of 12. So the actual y measurement there is 12, which you can see on the graph. Now remember, you're meant to do this without graphing. I'm just highlighting it to you to show you that it works whether you graph it or not. Using algebra again, we get 2 take away negative 2 for x being a length of 4. So y is 12 long, x is 4 long. So how does that help us find this? Well, our good old friend Pythagoras. So once you've done this to find what the length of the y line would be, the y actual vertical rise, and once you've found the length of the horizontal move of x, you then use Pythagoras. C squared equals a squared plus b squared. I've substituted in these values. I've used my calculator. I have got a total of 12.65. That means that this line, whether it be in centimetres or metres or whatever units we're using, would be 12.65 long. Pardon me. This is 4. The vertical rise of y is 12. So if that's 4, that's 12. Pythagoras tells us that that's 12.65. Now, a lot of really difficult algebra there. Don't expect you to remember it all at once. But what this can be helpful for you is that when you're preparing for tests and preparing for exams or trying to do your work, you can look back at different slides here, and you don't have to watch the whole thing every time. Just watch a particular slide or two to remind you of the correct methodology. Okay, see you all in class. Bye.